in the talk there is no single server, and this is a somewhat strange talk. You hear from my voice that I'm not a native speaker, so please, if I say something horribly wrong, just look very strange to me, and probably I'll get a grip then.
We're not native listeners either, don't
Great! Yeah, I saw on the Yahtzee page there were some people coming from Denmark and from Sweden and from whatever. Yeah, so we get through this, guys. Okay, there is no single server. Is a talk without too much code. There is some code, and it's not Perl code probably, and it deals with my experience in running something like a Perl-based toolchain for a company, which has several applications. And if people are asking what our applications are written in, it's very simple to answer. It's just everything, right? So we do have Java code, we do have Python code, we do have Ruby code, we have Perl code, we have lots of C and C++. So we mix everything. And I'm the one actually who is responsible for running the data center. So it's my headache that nothing runs there. Well, if I want to describe my job, a toolchain builder is probably my job description. I try to figure out what toolchains should look like. I try to build them. I try to build scalable toolchains. I try to build toolchains which are working, which are, well, actually they should work, they should make sense, and they should be somewhat scalable, right? It doesn't make sense if you have a toolchain which scales wonderfully, but it's just not usable. So I try to keep things together. This is from the introduction. Everything I'm saying here is it's a talk of fail and to find things and ways around it. It won't solve your problems. If you do have any problems, just get the teaser out of this talk and go and figure yourself, get in contact with me. Probably I can help you with something, but usually every problem has to be solved once, in every company at least 2 times. So the first time and the last time, usually you fix it twice. When I joined the company, that was something like 9 to 10 months ago, we had a very common server, and probably everyone has it in here. That's the superglue server. That's the server that glues everything. Right? There's no toolchain involved, there are no dependency tracking, there are no installations, there is just nothing, but it's a server. And basically what you can get out of this server is it runs some sort of OS. It could have been a Red Hat and it could have been a CentOS. Probably it was Ubuntu or Debian, but then someone said Slackware might be the way to go, so they introduced a way to go Apache Z packages on it. And then you have everything. Next thing is, it glues everything on one server. So you have the development environment running there. You have the something like a quality assurance environment there. And sometimes you even have production running on it. This server usually is highly critical, and it's very critical for your business. If this server isn't running, you won't make any money. Well, this is at least the case in my company. We do have some servers, and if those servers are not running, nothing works. Maintenance is always something interesting, especially when someone tried to compile Perl modules somewhere on some locations of the server and was doing some interesting stuff with the Perl 5 lib environment variables. Yeah, and you just can't shut it down because, hey, it is legacy, that's correct, but it runs your business. The company I'm working for has some problems. We have to actually deal with PCI DSS. I'm not sure if PCI DSS is something that is very common here in UK. Yes. Okay, yes. So the company I'm working for, that's the Wirecard, we're doing in credit card business. And we do have to fulfill PCI DSS requirements, and it's PCI DSS version 2, not version 1. And there's something, PCI actually, this is not readable, so sorry for that. That's Payment Card Industry Data Security Standards. That's PCI DSS stands for. It says something, one primary function per server only. And there's no explanation. What is one primary function per server only? Is it you can just have a web server running on it, but not an application server anymore? Or is it just a business application and you can't run another business application that are not related to each other on the same server? This is not very well defined actually. So when I started there was something like a vision and an idea, something like this. One primary function per server could also mean that you just are allowed to run one single function on a server and nothing more. Very easy. So here is it. This is our superglue, so a local server. It's a nice Mac Mini there. Usually it's not even a Mac Mini, it's something someone forgot in the data center somewhere and it's running. If you shut it down, everything fails unless it's running. So make sure to keep this one up, even if you don't know that it exists. And with the one primary function per server, you have this. So this server gets split into 3 servers. You have a web server, like we took the example of something like a web application there. You have a web server, you have an application stack, whatever that means, probably a Tomcat, or in our terms it's sometimes Mojolicious. And you have a database backend. Those environments are firewall, so there's a firewall between every server. So in order to keep the database stuff with potential credit card data which gets stored in there safe, you want to make sure that this is really a sane environment. The web server just gets the request from the front and actually just proxies it to the application server, but the web server is the only server in that stack that's accessible from the internet. So there's no way to access the application layer directly. Okay, so this was the idea, so let's start with it. That's one primary function per server. And I thought, hey, that was a really smart idea. And the next thing we have is, it even scales better, because you don't need a big box for the database if all the CPUs being used by the application server. So it scales better. It's a great idea. If you run into trouble with a web application, or with the application server, just add another few boxes and it should be fine. The database is still a problem there. And there was another thing that's not related to PCI, of course, but the development changed, at least in Germany, and the methodology is moving towards Scrum and all the agile stuff. So release early and often it was a buzzword a few years ago, but right now we do have it. In my company, they are doing weekly sprints in some of the product lines. So every week I have a potential release going on the servers. They are running continuous integration tools, so basically it builds Shipwright, is fine for them. And sometimes they do have crazy ideas, like we do need to have continuous deployment, so whenever we check something in, we want it on the servers, sometimes even on the production servers. So this is really a big problem and it's headache. So next thing I introduced staged environments. That was another idea. So development should be fine for everyone. Every developer should do just his job, whatever he wants to, that's fine. into the stacks we have there. We have the stacks for development. Everyone should just do whatever they want. We have an integration environment. The integration environment is something, well, probably a Jenkins runs on there, probably whatever you can use for test build tools. We have, what's it called? It's auto build. Yeah, you can run it there. Perl doesn't have something, well, at least not that I know of something like continuous integration, except someone is running make tests all the time. There is a continuous test runner, but I don't think that it's well maintained in the last years. Yeah, we have a QA environment. This is where the QA guys are testing everything. And something which is very important for our developers, as we are running load balanced environments, they want to test their applications the same way as the production is being used and configured. But there's a problem. The developers are not allowed to access the production environments because they can actually probably look into credit card data, and that's not allowed according to PCI DSS. We have another environment that's called customer test or user acceptance test environment. That's API level integration for customers who want to use our application. So this is just an API to the outer world. They can integrate, they can test, they can run their applications against our applications, and that's the reason for this stage environment. Yeah, and a little bit cool speaky here, right? Okay. We do have the production environment. Okay, so production environment is the full thing with 3 servers. And, oh, of course, and there's the first environment with service level agreements on this. So let's look into the concept of developers. Okay, very easy. We do have something called a stack server. A stack server is running everything on a single server, and that's probably something like the superglue server. So it runs web server application and database. The reason for this, or to have this server, is here's your server, everything you need. It's a great way to have probably setting up vagrant boxes or deploying virtual machines. Very easy to do. If someone wants to get into your business, give him the local machine and they're ready to start. But there's a difference between the last one, the superglue server, and this one. Make sure to automate the setup and configuration. You don't want to configure stuff manually on the server, starting from the stack server, starting from the development environment. They don't like this, actually. So here's a suggestion. We had one superglue server, everything running on this server, on this box. Virtualization is cheap, so the 10,000 foot overview over our one single server is something like we have a development environment. This is a stack server, single one. Integration, yeah, same. It's just running unit tests. It's running continuous integration tests, nothing more. Stack server, so everything on one box. Or everything on one virtual box. And then we have the environment for quality. This is just the full stack, so the web server, the application server, and the database server. But we double this in order to survive one failure of a box. So you can still turn off one box when everything's running. So if there's this two times full for testing, this means 6 servers. So 2 web servers in order to have one probably going down, 2 application servers, 2 database servers. The reason why we have this in the quality environment is we do have load balancers in front, and web application tends to get messy when load balancers are getting involved there. So usually this is a problem. They want to test it, that's okay. So let's introduce something like this. The customer test, that was the integration part. very easy. Stack server is sufficient. And production, okay, yeah, 2 times full for redundancy. Hey, virtualization is cheap. So now comes the great questions. How many servers do we have now from the one single server that we started with our superglue server? Does someone?
9.
Okay.
23.
Yeah, that was the right one. 15. That's 1 for development, 1 for integration, 1 for user acceptance tests, but 6 and 6 for prod. If I know, is it 15? Yes. Yeah. Great. So now we're at 15 servers. We're starting from 1, but this one is actually maintainable. Not maintainable, it's maintainable, sorry. It's very easy to update because you always have 2 servers for the critical parts of your application stack. So you can always take one down, update it, bring it back again and do the other one. So if your application can deal with it and can deal with session failovers, you should be safe. Ooh, yeah, so that's 15 servers. I do have some environments. I'm not sure how many there were when we started. I think it was something like 50, 60, multiplied by 50 now. So we had some growth over the last month. I see strange, or I see faces looking somewhat. Really? This is the truth. It works that way. With the new servers, we are running Intel servers from HP. We're able to run something like 50 servers on one box without any problems, running VMware on Red Hat 6. Works. So VMware is the virtualization layer, and we are running Red Hat 6 on top of it. And it works quite well. So this introduces some new problems. Granted, it's always wonderful if you introduce new problems when you try to solve old ones. So you have a new server, you can configure everything, great. And it looks fair to me actually. But you do have problems in terms of how do you split your configuration, how you do deployments, how you actually do the real deployment of applications without interfering with your production environment. Great thing, we have lots of fun with it. And I said, awesome. So let's look for the next tools. Virtualization makes it very easy to set up new servers. So, okay, we solved the problems of the superglue server. We have a redundant environment. Great, wonderful. So let's start with looking for the tools for those problems. Yeah, there are some. For the configuration of things, Puppet, Chef, Func, Sort, whatever they call it, I think there are only 2 which are, I would say, scalable and suitable for more or less big environments, and that's Puppet and Chef. I know that the Fedora guys are working on Func, but I think they use Puppet to manage all the infrastructure. And what I saw from the cpan I think is already depends on Puppet, and they're using it to set up the whole cpan sites. And we have another problem, or we have another toolchain there. That's the deployment toolchain. This depends actually what you're using for your base distribution if you're running Linux. So probably you have RPM or Debian packages, but there are a few other things. We should add ppm there for Windows. Yeah. Welcome to the next problem. There's just no tool that you can use for doing both. You can use Puppet or Chef for distributing files, but this doesn't scale. If you're having I have some huge environments scattered all over the world running in Amazon clouds, and if all those servers are calling back home to say, can you give me the latest file at this distance scale? So we need a toolchain. Okay, great. Next problem, next solution. Everything for testing is running test more. And when I mean everything for testing is running test more, this is, well, actually we're starting working on this for the non-Perl parts. So we're using this for Java applications. We're using this, or we start to use this for shell scripts, huge collection of shell scripts. And we are running test more to see what they're doing. For the deployment, we have chosen RPM, and for the configuration, we chose Puppet. When we started with the project, we had something like a set of rules. What's the best way to configure stuff? And we decided that it's probably the same way to keep everything separate. So you don't want to have something which builds stuff for you, which tests stuff for you, which configures and all monitors. There are some people who are doing this. And I saw, when I'm looking at the Puppet stuff right now, what they have on their website, there are some modules which are doing everything. They're doing the firewall configuration, they're doing the deployment, they're copying files, they're restarting service, they're doing everything. Problem here is you introduce lots of different cross dependencies, which are not written here. So let's look into a few things and now get back to the practical things and leaving the theory. First problem, shipping Perl. You can use the Perl from Red Hat. Is someone here who uses Red Hat? Awesome, 2 people, great. Do you know the version of Perl that's running on Red Hat? 6? Could you say it loud, please?
Maybe.
Oh, you're running Red Hat 5 then. It's 5.10. 5.10. 5.10.1. Probably with something like 1 million patches for fixing security problems. But yeah, we are running 5.10.1. Awesome. So here are some reasons why we want to ship Perl on our production servers for newer versions. I'm someone who's, well, at least has something to do with the Mojolicious project, the web framework, and we always have a problem in keeping up the support for Red Hat 6 because 5.10.1 is just horrible. We at least want to have something like 5.40. Probably 5.16 is the way to go. Another thing, and this is awesome, there are only Red Hat problems on this slide. Red Hat has some very interesting idea how to deal with Perl. They have a Perl distribution. Okay, very easy, you can install it. But they are splitting parts of the modules to separate packages. For example, if you install a server on Red Hat and you install Perl on it, there's no way to run the make script on it or the Makefile PL because there's no MakeMaker installed. You have to install it yourself. Okay, great. This is a great way to introduce new dependency problems. Use Red Hat. And another thing is, if you have your own software, if you have your own probably application you're shipping, you want to nail down dependency to certain versions. This is something which gives us headaches and Mojolicious because there are some bugs in IO socket SSL. This is a great thing. IO socket SSL ships per default with active state Perl and strawberry Perl on Windows because it's not that easy to compile it. You need some patches for that, and it's broken. That's great. So in the Mojolicious framework, we want to make sure that if there's a certain version, we don't want to use IO-socket SSL. We need to do something different there. So nailing down dependency is a problem, at least for your application. And if you ship your application to someone, you want to make sure that you have a sane environment. Probably you have something like a Nucleus running there. So why don't ship your own Perl? There are a few ways to do this. Perl brew probably is already well known here. It's a great way. It's a very small shell script which allows you to build. It's a small toolchain and works. Okay. It allows you to maintain your own Perl distributions. They get installed in your home directory or in the directory you specify, and then you can have all the different Perl you want to run or want to test. So you can actually run 5.10, 5.12, 5.13 with 14 with separate side Perls, so you can have the modules you want there. Another thing, and this is a fine tool, but it's a little bit rough. The idea is great, but it needs some love. That's Shipwright. We're going into this a little bit later. You can self-compile Perl. This is probably the worst idea you can have, because you're responsible for patching all the security things there. And you can use an external package management system. I'm a member of the NetBSD project. I'm a crowd member of the NetBSD project. NetBSD has a package system, and it is part of the NetBSD project, but you can use it not only on NetBSD, but it works on something like 13 platforms so far. It varies a little bit. It's the best way, and it's probably the most sane way to get software running on Solaris. But it's also a great way to run software for macOS 10. You can compile for macOS 10. And the current version we have in package source is 5.16.2. So NetBSD might be an old system. It's working. By the way, it's still alive. It's an old system, but the Perl parts in NetBSD are always, or in the package source tree of NetBSD, are always kept up to date. Yeah, this is great. I really would like to just spend something like 4 to 5 minutes to get there. What's the way to get it started? Very easy. Check out the sources. Yeah, we're using CVS. It still works. You bootstrap something. Okay, the reason why you should bootstrap package source is very simple. Because all the Linuxes ship with broken SH shells. Ubuntu, for example, doesn't ship bash per default. It ships ash. I don't know what ash is, but it ships ash and symlinks ash to bash. And if you install bash, you get the full bash.
I thought it's stash, the Debian Enquist shell.
Oh, sorry.
And it's actually introduced by Debian for
Okay.
squeeze. And besides, what's your definition of broken? The not POSIX compatibility of
Yes.
the shell? Okay.
Yes.
Well,
Well, that's the reason for NetBSD to exist, right? POSIX compatibility. Well, that's the reason why we're doing this there. I would say broken, right? But sometimes when you're looking into things, for example, how many arguments does the POSIX shell support, and you have a shell that doesn't support all those arguments, you have a way to deal with it. The best way is, so we ship the SH, we ship the make, which is the BSD make, okay, just to make sure that we keep things consistent for our toolchain. We're shipping a toolchain there. You can install it, that's the bootstrap command, and we're installing it in our home directory there, and then you can install everything there with the commands, with the 2 command lines below. Therefore, we install Perl 5, but you can, there's no problem in installing KDE in your home directory. It works. I don't know why someone would like to do this, but it works. By the way, that's a great way to have binaries on your server on university, where you're not allowed to install everything. As long as you keep in your home directory, you're sane, and this is a great way to do this. Because we're doing dependency tracking as well. This is something I just mentioned in a single sentence in the beginning of the talk, but don't mess with the Perl from your system. I did that, and I had a nice weekend for that. I installed some Perl modules in the same way, what I thought, using the system Perl, and I used with the Perl 5 inkpad. Great way to introduce trouble into your infrastructure and you have a hard time finding it. What is the package that Perl refers to right now? Great. So let's move a little bit faster so that we can have some time for the deployment then. So now we have a Perl on our system. Yay! And it's sane, it's working. Great! What about cpan modules? So we need to install cpan modules. Here are some. And those are all the Perlish tools. Probably not everyone knows them. Bundlefly, or from the research of the talk, I stumbled across Bundlefly. Okay, awesome. Shipwright, we're dealing with this. The cpan bundle, that's probably the oldest one. I'm using Perl for something like 20 years now. And I know how bundles are working, but I was something, well, hey, that's a way to do it. Cool. The power packer packs everything together, and I really would like to look into a few things. Here, let's start with the bundle stuff. First question, who knows how Perl bundles are working? Great, 1 people, and it's in Perl something, I don't know. Is it in Perl since Perl 4? 3, 2, 1?
Well, Perl 4 didn't have modules, so probably not.
Great! It's standard in cpan. I never used it. I always saw it. When I worked with the cpan shell, I saw something like, hey, there's the bundle stuff. You can search for bundles. What are bundles? Okay, skip over that and install the modules. First thing, there's a tool, auto bundle. You just type it on, it should be on your system, you just type it on, and then it builds a file with all the modules on your system. Okay, easy. And you can have personal bundles. Look into the personal bundles. I just got somewhere, so here we go. Bundle math. Is it, that's not you, Stefan, right?
No.
No, that's the Genoma, sorry. Here's it. How does it look like? Is it readable from your side here? So, okay, we do have a standard Perl package. No magic there. We have the changes file, the manifest file, the Makefile PL, and the math PM. And the Makefile just says, hey, my name is Bundle Math. And the version comes from Math PM. So what's in Math PM? This is so simple. Yeah, that should be readable. Okay. You just have something like a pod page. Very easy. And inside the pod page, in the contents, you list all the modules you want to have installed. That's all. That's a way to install bundle chains. So, 9 minutes left. Let's speed up a little bit. The Bundlefly things, something new. What he's doing actually is he uses graph directed to find out the dependency chain for modules and then put it in the right order. So there's not the permanent question, should I follow? Those are prerequisites. Should I install them as well? This is a way to deal with that. But this leads to trouble and anger. Right now we only can install cpan modules. Great! And here is the way to do it. I have a server. That's the first server and I installed it. I have Mojolicious version 2.5. Mojolicious, by the way, is famous for breaking backwards compatibility. But usually we announce that a few versions before we do. And then the time goes on and the box is getting too small and we need another box. So let's install it. Here's another one. Okay, cool. We install cpan moves on, of course. Cpan doesn't stop, never stop. And now we have another server running a different version of Mojolicious. Ooh. Okay. What about your application? Have you tested it? No. Why? Okay, probably you tested it, but you're running 2.5 in production for the Mojolicious, and now you introduced 2.52, so you should update your production server. So this is a problem. We need something that do versioning for us. There is something. Shipwright. Never heard of that before. Tested it, and it works great, but it's very rough. It's from Best Practical. That's the guys who brought us the RT, the famous RT. They are building, or the terminology they're using, they have a shipwright and there are vessels in it. The vessel can be something like the HTTP server there. There's an old version. You import it. So first you create the shipwright. So you have the shipwright, nothing in there. Then you have the possibility to import sources, and then you can release vessels from the shipwright certainly with dependencies listed. Awesome. You can update your version control with imported resources. It works. You can work with Git, SVN, and several other backends, and it's working reasonable. This is a great way to ship applications. You can even ship Perl with it. Cool. And another way, there we are, get back. Package source. We do have something like 4,000 modules available. Sometimes tend to be a little bit older than other ones. Sorry for that, we accept patches. But right now we are talking about our application, so what we can do is package source uses categories, so this won't be readable either. So we do have a devil category, and then we have all the packages for the devil. We have something like X11, and then we have all the stuff there, the KDE category. Introduce your own category. Just 3 files make a package. That's the description. Okay, easy, nothing to say about. The dist info with some checksums, so if someone tries to get bad code into your repositories, this won't work. And a Makefile with build instructions, and there is a Makefile. Yeah, it's very easy, but something that's really important for us is we do dependency tracking for native libraries. This tends to be messy when you just rely on cpan only. By the way, there's a way in cpan to deal with it, but nobody uses it. And we can depend on certain versions. That's also possible. Very easy to do. Another way to do this is with RPMs. You need to think the Red Hat way. So once you have the broken mind in your mind, it works reasonably well. But until then, you have our time to figure out what's going on. An RPM file consists of 2 files. There's a spec file. It's just the description how to build it, and the sources. The sources can be everything. You don't need to package everything into a TAR-GZ file. You can even have single files. RPM glues them together into an RPM package that can be installed. How does the description, the spec file looks like? Yeah, easy, right? Great, yeah. It's a little bit longer. But here's the interesting part of it. You can also specify exactly what versions do you expect to be installed. There's, for example, the first line, everything better than 5.10 is fine for the job. That's the same way you can do it. You can nail down the dependencies. And what's going on if someone nails down the dependencies to Mojolicious 2.5, and there's a newer version, this package won't get updated. So this is a way to deal with the dependency tracking of your application to the installed dependencies on the server. Okay, 3 minutes left, and some slides to go, but let's go for this. This is nothing new to you. You all know how to install RPMs. Probably it's the same way as with Debian, as you only have sudo apt-get and the package name. And with package source, it's package app. It's even simpler than. The package add command, this is the same as the one on FreeBSD, this is the same one as for OpenBSD, this is the same one as for Dragonfly BSD, so all the BSDs actually try to have the same command line language there. So now comes the fun part, and that's probably the part where you hear. We build our software, we have all the infrastructure available, we package everything, we're able to ship it, but what's the way to configure it? We're using Puppet for that, and Puppet is the way to go, I think. It's written in Ruby, which is a problem, at least for me. You have resources, so everything in Puppet is resource-based. A file is a resource, a package is a resource, a service is a resource, everything is a resource, and you can have certain methods running on the resources for certain functions. Client-server-based module, SSL-based, and they have a module concept, and that's what I want to look into. A module in Puppet, very simple. Yeah, just a skeleton there. Module, inside the module we have a manifests folder, and inside you have an init.pp. This is the smallest Puppet module possible. There's no way to have it shorter. You can call it outside. In this case, that's class module, and then you can pass some parameters. So now here comes the 1 minute thing. So let's have the one from Mojolicious. This is a fully working class in terms of Puppet for installing the Perl Mojolicious package. In this case, it doesn't matter. The naming shows that it's a Red Hat based version, but change the name here to a Debian version and you can even manage Debian without changing the code there. What it does is, okay, we have a variable called app destination. This is just the place where we want to have our applications in the later time. And then we're installing the package for Mojolicious, and we always want to have the latest version. We can nail this down to certain versions then. We need to create a few files there so that we can place our application somewhere on the server. And what we see here is the file is the same as a directory. It's just a Puppet. In Puppet terms, it is a file resource. It's a file, but this is the type of the file is a directory. So I can give you it. So next thing, we have our applications and we wrote it. It's called Perl Mojolicious My Application. We want to make sure that the latest version is on the server. There's a missing bracket, sorry for that, here. We require that the destination for the files we're going to copy the files into is existent. And we do a notify. And here's the fun part. When there's a new version for this application, and Puppet runs on the server and sees, oh, here's the new version, it notifies the exec. And what does the exec do? The exec reloads the Mojolicious application. This is the refresh only. And only when this one is being notified from the outer world, so I have a new package, I have an event, hey, I have a new package, this one is getting reloaded. So what we do have right now is a fully automatic deployment. Once we have a new package, once we provide a new package and the server finds a new package, it does everything for us. 2 slides to go, we get that. Recap. Okay, what we saw here is we have dealt with Perl, we dealt with modules and cpan dependencies. We have a way to find deployments. We can configure our applications and we can have them reloaded on the fly just by defining the state. And here's another one. If you go the way to control your infrastructure with Puppet, you should do this consistently. So probably you have the load balancer in Puppet as well. if you're using LDS, for example. There's a cool plugin. It's inside the Mojolicious core, and it's the powered by plugin. If you don't use it, it just says X powered by Mojolicious Perl. But you can set it actually, and you can have the X powered by, and you can set a version to this, and make the load balancer help scripts check for the version string. So this is a great way to get a server back into the farm with a new application and to keep the older ones out of there. This helps you scaling. Right now I have something like, I don't know how many web servers, and they are running different applications. I'm using Puppet to have them deployed the RPM. They fall out of the load balancing at the first start. I have to update a few servers in the beginning. And once they have the sources, they get back into the load balancing. We are already 5 minutes over the time, but all the code for the Mojolicious part and how to deploy things will be on my GitHub repository probably by tomorrow evening. If you need some code examples for how we can package RPMs from our applications, how we can have something like automated updating and Puppet, so just give me a call. Here's my email, here's my Twitter account, follow me on Twitter. Just ask. This was just a talk for teasing into several things, and as I said, I won't solve your problems, but probably you have a few ideas how to get around that. So thank you for your time.